Okay, so I want to start encoding some RIP relative addressing. So here we'll just do rel dollar plus some displacement. We'll include some 32-bit ones. They're always a 32-bit displacement anyway, but I just want to make sure. So we'll do, for example, -1, minus some byte value, and then another one. And then similar to here, I'm doing this explicit zero displacement. I want to add a couple of tests up here with explicit zero displacement because in some cases I shouldn't actually be emitting it. So for example, RCX plus 0 should really just be encoded as RCX without a displacement. But in the cases of, for example, RBP and R13, I do still need the displacement even if, it's being set as explicit 0. I don't want to omit that. So if we go to the encoder test, I'll just add those explicit 0 displacements here. So this was CX, then we had BP and R13. And then down here I'll need the RIP relative tests. So each of these is going to be MOV, op MOV, and they're all going to be D-word. They're all going to do something with CX, NA, NA, and all of these displacements are relative to the instruction pointer. So I'll do IP as a memory access and then add a displacement. Where the displacement is just these things, so I'll just take these. I think in Go for this 8.1 I need to put a minus sign, otherwise it's going to complain about overflow. Okay, and let's regenerate the NASM listing and run the tests. Oh, this is going to complain about IP actually, so let's just add that first. So IP, I'm going to need to know that it's RIP relative, which is always a relative displacement, 32 bits, so I'll call this rel32. And the value for this is disp32 here, which is 5 for the index, so that's already correct. So if I run this, rel32 also needs to be defined. So rel32. Okay, so we get some failing tests. This RCX plus 0, I am actually outputting the 0 byte even though I don't need to. So I think the way I want to deal with that is to just say that if disp is equal to 0, we'll just return the operand unmodified. And then that's broken these two. So that's broken BP and R13, because now it's not adding the displacement, even though those two actually need it to be encoded. So I think that is because in the case where it's membp and it's not a displacement, I explicitly use this D function, but that's now not doing anything, so I'll just explicitly set the disp flag here. And actually, while I'm here, I think this could actually just be a switch. So we'll just change this to a switch. Case. Okay, let's just put this up here. Okay, so now we just have the RIP relative stuff. So it looks like the mod RM is incorrect. So in my what we want is 0D, for example, but I'm outputting 4D, which means that I'm setting the mod, which are the two high bits, to 0.1. And then this is obviously 0.0 here, which is becoming 4 in my one. But mod always needs to be 0.0 for the RIP relative disp32 encoding, because that is in this row here, which is always mod 0. So this is where mod is being modified. So I only want to do this if it's no base and if it's not rel32. But this is going to match an exact mask. So if I just do is any and just make a new helper for this. So is any is going to be the same sort of thing, but it's just going to check to see if any of the bits are set. Okay, so the mod RM is being set correctly now, but I'm not outputting any displacement. So that is down here. So IP is already a displacement. We're not modifying mod anymore, so it falls down into default. And then I need to check if it's rel 32 here as well. And in that case, I want to output the 32-bit displacement. Okay, so now it's outputting it, but the displacement is incorrect. So for example here, I've done a displacement with 7F on the end, so my one is outputting 7F, but NASM is outputting 7.9. And that's because rip relative is relative to the instruction pointer, which will be after the current instruction, but we're defining the displacement according to the beginning of the current instruction. So for example, this 7F here, if we count the bytes in the final encoded instruction, this is 1, 2, 3, 4, 5, 6. So 7F minus 6 is equal to 7.9. So that's where this 7.9 is coming from here. So we have to subtract the length of the instruction to encode it as if we are defining it from the end of the instruction instead of the beginning. So in that case, I need to say that if RM is rel 32, then displacement needs to have something subtracted from it, which will basically be the difference between the number of bytes generated at this point and the number of bytes that were at the start of the function. So we'll keep track of that with n. So that'll be e.code, that'll be the length of the code generated before we start generating anything. And then we want to take the length again and minus that n. And then we want to add, we need to subtract an additional 4 bytes because that's how big the displacement will be as well. So let's just try this. Mismatch types int32, yeah, okay. So this needs to convert to int32. Okay, so that takes care of rip relative addressing and explicit 0 displacements, which don't need to be emitted. I'm just going to quickly clean up this code here. This can actually just be out here, which also means actually that I can just change this to a bytes case and move this rex thing into the byte case. Go test. Okay, so I think I'm getting to the point now where I want to start doing things like switching, allowing flipping the operands around. So right now I've been assuming that RM is always in the destination, but that could obviously be in the source if memory access is needed in the source and stuff like that. So I think that's what I'll get onto next.